I'm Angel Paul, and I would like to explain in brief the introduction and working of Go Back in ARQ. The problem statement given to us is to implement Go Back in ARQ in a noisy channel in C, C++, or Java. We have chosen to implement it in C. Go Back in ARQ is a specific instance of the automatic repeat request protocol, which is nothing but ARQ, in which the sending process continues to send a number of frames specified by a window size even without receiving an acknowledgement packet from the receiver. It is a special case of the general sliding window protocol with the transmit window of size n and the receiver's window of size 1. Now moving on to why is it actually called go back n. I would like to explain this with an example. So let us consider that the sender wants to send 10 frames, and while receiving these 10 frames, the 4th frame does not reach the receiver because it would have been lost during the transmission or it would have been damaged, and the receiver wants the sender to resend it. But the sender would have sent all the frames from 5 to 10, and all these frames would have been discarded by the receiver. So the frames from 4 to 10 will have to be resent by the sender. There goes the go back by n frames. Moving on to the working. So let us consider that m is equals to 2, which means that the window in the sender's frame will have 2 to the power m minus 1 frames. That is 3 frames. S and R are the pointers to track the movement of the frames in the sender's and the receiver's ends, respectively. SF and SL are the first and the last frames in the window. Initially, the frame 0 is being sent and is being received by the receiver. The same thing happens in the frame 1. SNR points to 1. An acknowledgement is being sent from the receiver to the sender saying that the frame 2 is being acknowledged, but due to which the window slides to the 3 next frames starting from the frame 2. But while sending the frame 2, it is being lost during the transmission. Now R still points to 2. The sender side does not know that the frame 2 was being lost, due to which it keeps sending the frames. Now the frame 3 is being transmitted, it reaches safely, but it is not being considered by the receiver. It discards the frame 3. Now the frame 2 is being resent from the sender side and reaches safely, and it sends an acknowledgement of the frame 3. Now the window slides to the next 3 frames starting from frame 3. The frame 3 is being resent, received by the receiver, and the process continues.
So this is the program for Go Back N ARQ. Here the sender should send more than one data frames which is written within the window size and start a timer for it. If it receives acknowledgement, then it should move its sending window and reset the timer to the first outstanding frame and then send the next set of frames. If it does not receive acknowledgement before the timer times out, it should retransmit all the outstanding frames, that is those frames which have not yet received any acknowledgement. Here the program is coded in C language. We first have some header files. Some of the basic ones are stdlib.h and stdio.h. Next we have stdbool.h. This header file is needed for using variables of Boolean data type, that is they can have two types of values, that is true and false. Next we have the header file time.h. This header file has functions to get and manipulate date and time information. So next there are a set of variables that are being initialized. To talk about these variables, first we have the total time of the data type integer. This is initialized to 0. Here the total time is the time that is taken totally for generation and transmission of the packets. In case if the packets are lost in the transit, then the total time will even include the timeout time. Next we have the percentage efficiency. Here the efficiency is stored in terms of percentage. That's why we use it in float data type. Here efficiency basically means the number of packets that are received by the receiver. Next we have the number of packets that is lost. It will be stored in num packets lost variable. Next we have an array of integer data type, that is sender of 10 and of 4. Here we have the number of rows is 10, because in this program basically we'll be assuming that the maximum number of packets will be 11, so we have given 10, and then this 4 it will basically store 4 different types of information about the sender packets. So these information are basically like if the index number is 0, then we'll store the packet number. Then if the index number is 1, we'll store the generation time, and if the index number is 2, if the packets reach safely, then we'll use the index number 2 to store the generation time plus 2 into transition time. Here it is 2 into transition time because one is transition from the sender to the receiver and another one from the receiver to the sender. Next, if the packets are lost in the transit, then we'll use the index number 3 to store the generation time plus timeout. So the next variable is SWP to send. This is the sliding window protocol at the sender side. It is a window frame that has a number of packets. So this variable will store that. Similarly, we even have SWP to receive. Next is the in transmission time. Transmission time means it is time required for transmission of packets from sender to receiver. And then we have the generation time. It is the time required to generate the packets before transmission. Next we have the timeout. It is a time before which the sender must receive an acknowledgement from the receiver that the packets have been reached safely. If the acknowledgement is not received before the timeout time, then the packets must have been lost in the transit. Next we'll go to the in part where we'll be inputting certain things from the user. First is generation time, transmission time, a timeout time, and the efficiency in percentage. Using this, we can calculate the number of packets lost. Since efficiency is in terms of percentage, the total number will be 100. And 100 minus the efficiency will give you the number of packets lost. Since the efficiency is in percentage, it's a float data type, it will be typecasted to int since the number of packets must be an integer value. Next we print the ending and we call the go back end function. Here before going to the go back end function, the go back end function uses the generate status function. It is of the return type void. It uses 2 parameters. That is generation time and packet number. So here first they check if the packet number is lesser than 11. This is because, as I told earlier, here we in this program we assume that the maximum packet size is 11. So if it's lesser than 11, we print the packet number along with its generation time, and then we give information in the sender array. Here if you take those 4 columns where we store the information, at the 0th index we store the packet number, at 1 the generation time, and 2 and 3 is first initialized to 0. Then here we have a variable that is called as rantemp. The rantemp basically stores the packet number. Here randomly any packet will be lost during the transit, and this variable will store the packet number that is being lost. Here because we randomly take the value, we'll use the randomer function which generates any random value, and then that value mod 100 will be stored in rantemp. First we check if rantemp is lesser than the number of packets lost. If it's true, it means that the packet will be lost in the transit. If it's false, it means that the packet will be reaching safely. First we check for the condition, and if it's true, we go into the if block. In the if block, if the packet is lesser than 11, we check the condition, and then we print that the packet will be lost in transit. Since it's lost in transit, as I said earlier, generation time plus timeout will be stored at the index number 3, and index number 2 will just be 0. If the rantemp is greater than the number of packets lost, then we'll go to the else block. Here we again check if the packet number is lesser than 11, then we print that this packet will reach safely, and then at the index number 2 we store the information generation time plus 2 into transmission time, as I said earlier. 2 into transmission time because one is from the sender to the receiver, other one is from the receiver to the sender time. We store this into the index number 2, and 3 will be 0.
Hi all, I'm Shriya and I'm going to explain the implementation part of go back end function. So in go back end function, basically here we have our nested for loop, where we have initialized a 2-dimensional array called sender I, J20. So based on the condition that we have declared the array, we have initialized it using a nested for loop. So we have initialized packet number to value 1. So then we have entered a while loop. So initially, since a packet cannot be lost, so we've initialized the timeout variable to false. So it's a boolean data type. So we have initialized it to false. So in this, so as my friend has already told you before, so in senders, sliding window protocol, in second position of the array, we have used it to store the acknowledgement time, and in the third position of that array, we have used it to store the timeout time. So there will be two situations where two types of acknowledgement can occur. One situation is that where your acknowledgement reaches the sender within the stipulated amount of time. And the second time is that when the acknowledgement reaches the sender after the timeout takes place. So this is the first situation where your acknowledgement reaches the sender within the stipulated amount of time. So as I told you before, this basically is second position. We have stored the acknowledgement time. So if that time is actually less than, so here SW to receive is nothing but sliding window. So if that time of that window, the acknowledgement time of that window is actually less than total time plus the generation time. And obviously, so this value should actually not be equal to 0. So then it means that the packet has reached the sender within the time that the timer has expired. So hence the packet can be acknowledged. So the packet number has been acknowledged. So with respect to sender, and this is the sliding window protocol of that window. And as I told you before, 0 is used for packet number, and 2 is nothing but the acknowledgement time. So this will give you the time with which the time taken for that packet to reach the sender back, and this is nothing but the packet number which has reached the sender. So now this is a condition to break out. So as in the program we have declared, we have assumed the hard-coded value of the maximum number of packets to be 11. So if the number of packets are 10, then we exit out of the while. So that is the reason why we have used this if condition and break. So this is because if the number of maximum packets are greater than is equal to 10, then we come out of the while. So in this, what we do in this statement is that, so we actually increment the sliding window protocol. So for that, for incrementing the sliding window protocol, we have used this. So we actually add 1 more 10 will actually help us to increment the sliding window protocol at the receiving side. So this is at the receiving side. So now as I told you, there will be 2 conditions of acknowledgement. So this is the second condition where your acknowledgement has reached the sender after the timeout has occurred. So after the timeout has expired, the acknowledgement has reached the sender. So in this line, so here as I told you, in position 3, it is used to store the acknowledgement time. So this is, as I told you before, this is the sliding window protocol. So this time is actually less than the total time plus generation time, and this value obviously will not be equal to 0. Then it indicates that the timeout has occurred. So it means that the packet has reached the sender after the acknowledgement has reached the sender after the timeout has occurred. So in that condition, what you do is that we print that the timeout of packet number has occurred and time. So this is, as I told you before, this is for 0th position for the packet number, and 3rd position is for the timeout time. So in 3rd position, we are storing the timeout time. So here we get the timeout time of the packet. So then now, if suppose the acknowledgement has reached the sender after the timeout time, then after that all the packets have to be sent. So if suppose the packet number 4 has lost, so from packet number 4, whatever is acknowledged packet that has to be sent, it will all be resent. So even though those packets have reached safely, all those packets will be resent. So here we use the concept of cumulative acknowledgement. So whatever is the sliding window protocol of the receiver, so we store that to sender. Just because from there on, all the packets have to be resent. So that is the reason why we have initialized it. Then, so in this line, what we are doing is that so sliding window protocol, so that packet number, so whatever is sliding window protocol of the receiver, that packet number is basically stored in to the packet number, and here we initialize that since timeout has occurred, we initialize timeout occurred to true. Then So in general, we calculate the total time. So initially we initialize the total time as 0. So now we calculate the total time as total time plus generation time. Now if timeout has occurred, then your total time will be whatever is the timeout time. So since timeout time is stored in array of 3, so whatever is the sliding window protocol to receive and in third position, that time will actually be the total time. So whatever is the timeout time that has occurred, that will actually be the total time in case the timeout has occurred. So here, if sender SWT to receive of 0 is equal to 0, so this line is basically tells us that this is the first, if it is the first packet, okay, so then initially it will be 0. So we call the function generate status and we pass total time and packet number, and this function has already been explained by my friend. So then we increment the packet to packet number, and we again increment the sliding window at the sender side to point to the next position. Then again, so if it is not the case, if it is from the second packet onwards, then we can calculate it using this formula. So sliding window protocol 2 at the sender side minus 1 plus 10 mod 10 at 0 position will basically give you that packet number other than the first packet now. So then we continuously check if those packets are less than 11. Since I'm again repeating, this 11 is a hard-coded value. Maximum number of packets that we are sending is what we have assumed. So if that is the case, then again we call the function generate status, pass the total time and the packet number, increment the packet number, and again increment the sliding window protocol at the sender side. Yeah, thank you.
Hi, I'm Ananya and I'll be explaining the result part of the code. So we take in the generation time, transmission time, timeout time, and the percentage efficiency from the user. The percentage efficiency is based on the number of packets lost during the transmission. Before we go through the rest of the code, we need to know that when a packet is lost during its transmission, the packet that is lost during its transmission and all other packets generated after that packet have to be retransmitted or resent. We will see this as we go through the rest of the result. Now, packet 1 is generated at time 40 milliseconds and this packet will reach the receiver safely. Similarly, packet 2 and 3 were also generated and managed to reach the receiver safely. When we come to packet 4, we notice that this packet was lost in its transit, which means packet 4 and all other packets which were generated after packet 4, that is packet 5, packet 6 and packet 7 had to be regenerated. But this will be done only when we come to packet 4. Until then, all the packets that reached the receiver safely, that is packet 1, 2 and 3 have to be acknowledged. So packet number 1 is being acknowledged at time 180 and packet 5 is generated at the time 200 milliseconds and reaches the receiver safely. Packet 2 was acknowledged and packet 6 was generated and reaches the receiver safely. Packet 3 was acknowledged and packet 7 was generated and reaches the receiver safely. We see that a timeout in the packet 4 has occurred at time 190 milliseconds. Why is this? This is because packet 4 was lost in its transit. This happened because packet 4 was failed to be acknowledged in the stipulated amount of time. So once the time was elapsed, we retransmit packet 4, 5, 6 and packet 7 and which will reach the receiver safely. We see that when packet 6 was generated, it was lost in its transit. We know that whenever a packet is lost in its transit, the packet that is lost in the transit and all other packets after that will be regenerated. But we will see this when we come to packet 6. Currently, until packet 3, the packets were acknowledged. We didn't acknowledge packet 4 because it was lost in its transit. But after resending the packet 4, 5, 6 and 7, we can now acknowledge packet 4. So packet 4 has been acknowledged at time 330 milliseconds and packet 8 is generated at time 350 milliseconds, and we see that again packet 8 was lost in its transit. We will see this when we come to packet 8. Meanwhile, packet 5 has been acknowledged and packet 9 was generated and reaches the receiver safely. When we come to acknowledgement of packet 6, we see that a timeout has occurred. Why is this? It is because packet 6 was lost in its transit. So packet 6, 7, 8 and 9 will have to be resent. So that was done. Packet 6 was resent, 7, 8 and 9. When it was generated again, we saw that packet 8 was lost in its transit. But until we come to packet 8, we will continue our usual process. Packet 6 was acknowledged and packet 10 was generated and lost in its transit. Now, we will see that once we come to packet 10. Now, packet 6 was acknowledged. We will continue acknowledging the consecutive packets. Packet 7 was acknowledged at time 480 seconds. When we came to packet 8, we see that the timeout has occurred. Why? Because we saw that packet 8 was lost in its transit. So all the packets after packet 8, that is packet 8, packet 9 and packet 10 had to be resent, and that was done. So packet 8 was generated, packet 9 was generated and packet 10 was generated. We saw that during the generation of packet 9, packet 9 was lost in its transit. So if packet 9 was lost in its transit, we know that including packet 9, the packet which was generated after packet 9, that is packet 10, would have to be resent. But now we see that we had acknowledged until packet 7. So we acknowledged packet 8. So once packet 8 was acknowledged, we come to acknowledge packet 9. But packet 9 was lost in its transit. So we see that a timeout has occurred when packet 9 went to be acknowledged, which means we had to generate packet 9 and 10 again. When we generated packet 9, it was again lost in its transit. So we saw that packet 9 was again lost in its transit. That means we had to generate packet 9 and 10 again. Once we generated packet 9 and 10 again, this time packet 9 and 10 reached the receiver safely. So packet 9 was acknowledged at time 650 milliseconds and packet 10 had been acknowledged at the time 690 milliseconds. Thank you.